Imagine standing at the base of a brand new $720 million glass giant in the heart of Buffalo, New York. It is sleek, it is modern, and it was supposed to be the crown jewel of the city's skyline. But as the winter wind begins to howl off Lake Erie, a sound starts to echo through the luxury lobbies. It isn't the sound of a heating system or the hum of an elevator. It is the sound of structural glass under extreme stress, snapping like a frozen twig. Deep within the core of this massive skyscraper, long jagged lines are appearing in the high-performance concrete, and the culprit isn't a structural error or a lack of funding. It is something much more embarrassing. The builders rushed the construction schedule so fast that they completed the exterior envelope before finishing the critical frost tests required for Buffalo's brutal climate. Now the city's newest monument is literally cracking through the floors, and engineers are scrambling to figure out if $700 million has just been poured into a sinking ship. In the world of massive construction projects, we usually talk about delays and budget overruns as the primary villains. But in the case of this Buffalo mega project, the villain was actually speed. Everyone wanted this building finished. The city needed the tax revenue, the developers needed the tenants, and the politicians needed the photo op. But when you build in a city like Buffalo, you are playing a dangerous game with the elements. Buffalo isn't just a place where it snows. It is a place where the temperature can drop 40 degrees in 6 hours, where the humidity from the lake turns into ice crystals that can penetrate the smallest microscopic gaps in a building's foundation. In the rush to beat the winter season, the construction team made a fatal decision. They skipped the full-scale frost heave simulation on the actual floor slabs before finishing the glass curtain wall. To understand why this is such a disaster, we have to look at the physics of a skyscraper. A building of this magnitude isn't just a static object sitting on the ground. It is a living, breathing entity that expands and contracts based on the weather. In professional engineering terms, we call this thermal movement. Usually, a building is designed with expansion joints that allow it to wiggle just a few millimeters when it gets cold. However, Buffalo's climate creates something much more aggressive than simple expansion. It creates frost heave. This happens when the moisture in the soil, or the moisture trapped within the concrete itself, freezes and expands with enough force to lift a tank. If you haven't accounted for the specific way your concrete mix reacts to the freeze-thaw cycle of upstate New York, those floors aren't just going to move, they are going to buckle. As the first major frost hit, the symptoms started to appear on the lower residential levels. It began with hairline fractures that the maintenance crew thought were just settling cracks. This is common in new buildings. Every skyscraper settles into the earth a bit in its first year, but these weren't settling cracks, they were growing. Within weeks, the cracks were wide enough to slide a credit card through. The occupants of the luxury units started noticing that their doors wouldn't close properly. Precision-engineered cabinetry was splitting at the seams. And then came the noise. The sound of a skyscraper cracking is something you never forget. It sounds like a low-frequency groan that resonates through your bones, followed by a sharp pop that sounds like a gunshot. The investigation into what went wrong has revealed a fascinating and terrifying sequence of events. Most mega projects of this scale utilize something called a mock-up test. This is where you build a section of the building in a laboratory and blast it with wind, water, and ice to see how it holds up. For this project, the mock-ups were theoretically approved, but there was a catch. The concrete mix used in the actual construction was slightly different from the laboratory version to speed up the pouring process. This high-efficiency mix was supposed to dry faster, allowing the cranes to move up to the next floor every few days. But this new mix lacked the specific air entrainment properties that allow concrete to survive deep frost. Without those tiny microscopic air bubbles, there was no room for the internal moisture to expand when it froze. Instead of expanding into air pockets, the ice expanded into the grain of the concrete, shattering it from the inside out. The situation is complicated by the $720 million price tag. When you spend that much money on a building, every day it sits empty or under repair is a financial disaster. Currently, the upper floors of the Buffalo skyscraper are technically stable, but the internal damage to the mechanical systems is mounting. As the floors crack, the pipes for the plumbing and the conduits for the electrical wiring are being pulled and stretched. If a main water line snaps on the 40th floor because the concrete slab beneath it shifted 5 millimeters, the water damage alone would cost millions. This is the nightmare scenario that the developers are facing right now. They are basically sitting on a ticking clock, waiting to see if the building will stabilize or if the next winter will bring even more dramatic fractures. How did this happen in 2026 with all our modern technology? It comes down to a fundamental misunderstanding of the local environment versus global building standards. Many of the lead designers on this project were from firms based in warmer climates. They used materials and assumptions that work perfectly in Chicago or Atlanta, but Buffalo is a different animal. The proximity to the lake creates a microclimate where the frost line can penetrate deeper than standard building codes anticipate. The frost test that was skipped wasn't just a formality, it was a localized assessment of how the specific soil chemistry of that site interacts with the high-strength concrete under sub-zero conditions. By moving forward with the project before those results were in, the developers gambled $700 million on the hope that the weather would be mild. The weather was not mild. The engineering community is now watching this project as a cautionary tale of what happens when fast-track construction goes wrong. Fast-tracking is a popular method where you start building the foundation and the lower floors while the upper floors are still being designed. It saves time, but it leaves zero room for error. In this case, by the time the field tests showed that the concrete was vulnerable to frost-induced cracking, the building was already 30 stories in the air. You can't just go back and replace the bottom 5 floors of a skyscraper. It's physically impossible. You have to find a way to reinforce what is already there, often through a process called carbon fiber wrapping or high-pressure epoxy injection. But even these solutions are controversial. Injecting epoxy into a structural crack might stop it from growing for a season, but it doesn't solve the underlying problem. The underlying problem is that the entire slab is susceptible to the temperature. Every time the thermometer dips below freezing, the internal tension in the building rises. Imagine the stress on the glass windows. These windows are bolted into the horizontal slabs. If the slab above moves one way and the slab below moves another, the window frame twists. High-performance glass can handle a lot of wind pressure, but it cannot handle a twisting torque. This is why residents have reported seeing the rainbow effect in their windows, which is a sign of extreme structural stress. It's only a matter of time before these massive panes start to shatter. The local government in Buffalo is now in a difficult position. They want the building to succeed because it represents the resurgence of the city, but they also have to protect the safety of the citizens. If the cracking continues to worsen, there is a real possibility that the building could be declared uninhabitable. Can you imagine the fallout of a $700 million building becoming a vertical ghost town because of a skipped frost test? The legal battles are already starting. The developers are blaming the concrete suppliers, the suppliers are blaming the engineering firm, and the engineering firm is pointing at the accelerated timeline demanded by the city officials. It is a massive circle of blame where everyone is trying to avoid being the one left holding the bill for a failing mega project. What makes this truly heartbreaking is that Buffalo has a rich history of architectural excellence. Some of the most sturdy and beautiful buildings in the country are located right there. Those older buildings were built with massive safety margins and an intimate understanding of the local snow loads and ice conditions. In our modern quest for efficiency and leaning out the materials, we have removed those safety margins. We are building skyscrapers that are so finely tuned that even a small deviation in the concrete's chemical makeup can lead to a catastrophic failure. This Buffalo skyscraper was designed with the absolute minimum amount of material required by code, leaving no room for the unexpected reality of a Buffalo blizzard. Experts are calling for a complete reevaluation of the building's core. They are suggesting that the only way to save the project is to install a massive, high-tech heating system that keeps the concrete slabs at a constant temperature year-round. Think about that for a second. To keep the building from cracking, they might have to spend millions of dollars a year just to heat the structural elements of the building so they never reach the freezing point. The energy costs alone would be astronomical, and it would completely destroy the building's green and sustainable certifications. It is a desperate solution for a desperate problem. For those watching from the outside, this is a prime example of why slow is smooth and smooth is fast in the world of construction. If they had waited just 3 months to get the results of the frost test, they could have adjusted the concrete mix. They could have added the proper chemical additives to protect against the freeze-thaw cycle. Those 3 months would have saved them hundreds of millions of dollars and protected the reputation of everyone involved. Instead, they took the shortcut and now they are paying the price. The cracks across the floors are more than just damage to the concrete. They are a visible reminder of what happens when human ego tries to outrun the laws of nature. The human element of this story is equally gripping. Imagine being a young professional who just bought a condo in this building. You spent your life savings on a high-floor unit with a view of the lake, only to wake up one morning and see a crack running across your kitchen island. You call the management, and they tell you it's just settling. But then you see the engineers in the lobby with laser levels and sonic scanners every single day. You see the glass in the lobby boarded up because it spontaneously cracked during the night. The anxiety of living in a failing mega project is something that isn't discussed enough. Your home is supposed to be the most stable place in your life, but when the very floors you walk on are under threat from the air temperature outside, that sense of security vanishes. As we move forward into 2026 and 2027, the fate of the Buffalo skyscraper remains uncertain. There are rumors of a massive retrofit that will involve drilling hundreds of steel piles through the foundation and into the bedrock to bypass the unstable soil layers, but the cost of that could push the project budget over the $1 billion mark. At that point, the building might never be profitable. It becomes a monument to architectural hubris. A skyscraper that was meant to symbolize a new era for Buffalo now stands as a warning to every other cold-climate city around the world. The lesson here is clear. You cannot build your way around the climate without fully understanding it first. Computer models are great, but they are only as good as the data you put into them. If you don't account for the unique, aggressive nature of a Buffalo winter, the environment will find the weak point in your design and it will exploit it. The frost test was the most important thing on the schedule, and it was the one thing they thought they could ignore. They were wrong. And now, the glass giant is groaning under the weight of that mistake. The engineering world is now debating whether the building can even be finished in its current state. Some suggest that they should stop construction on the interior finishes until they have a full cycle of weather data to see how much the building actually moves. But every day the building stays under construction is another day of lost interest on the loans. It's a financial trap. If they keep building, they might be installing expensive marble and electronics in rooms that will eventually bend and break. If they stop, the interest payments will eat the developer alive. There is no easy way out of this 72-floor disaster. As the wind picks up again tonight in Buffalo, the sensors inside the skyscraper are probably buzzing with activity. These sensors are tracking the movement of the cracks down to the thousandth of a millimeter. Every time the building twists, the data is pushed to a server where engineers halfway across the world are trying to model a solution. But the solution isn't in a computer. The solution was in that skipped frost test. It's a reminder that in the grand game of construction, nature always has the final move. You can spend $700 million on the most beautiful materials in the world, but if you don't respect the frost, it will tear your building apart from the inside out. The city of Buffalo has seen a lot of ups and downs, but this is a uniquely modern tragedy. It represents a collision between the high-stakes world of international real estate and the uncompromising reality of the Great Lakes weather. For now, the building continues to stand, a gleaming glass tower that from a distance looks perfect. But if you get close enough, if you listen carefully in the quiet of a winter night, you can hear the building struggling against itself. You can hear the floors cracking, a $700 million ghost in the machine. What happens next will set the tone for mega projects for the next decade. Will insurers continue to cover these high-risk, fast-track buildings? Will cities demand more rigorous on-site testing before allowing developers to proceed? One thing is for sure, nobody in Buffalo will ever look at a new skyscraper the same way again. They know that what looks strong on the outside might be crumbling on the inside, all because someone forgot to check the thermometer before they started pouring the concrete. The story of the Buffalo glass giant is still being written, but the first chapters are a masterclass in how not to manage a failing mega project. It's a story about the importance of the mundane details, the chemical composition of concrete, the depth of the frost line, the patience to wait for a laboratory result. In our world of instant gratification and high-speed growth, those details often seem boring. But as the people of Buffalo are finding out, those boring details are the only thing keeping $700 million from turning into a pile of cracked glass and broken concrete. As we watch the cranes continue to move, albeit more slowly now, we have to wonder if they are just throwing good money after bad. Is it possible to save a building that was born with such a fundamental flaw? Only time, and many more Buffalo winters will tell. For now, the skyscraper remains a giant question mark on the horizon, a monument to the fact that you can build as high as you want, but you are always at the mercy of the ground beneath your feet and the air around your windows. The frost test wasn't just a hurdle to jump over. It was the foundation of the building's entire future. Without it, the 100-story dream is struggling to stay in one piece. This is the reality of modern engineering when it loses its connection to the local environment. It's a high-stakes gamble where the house always wins. In this case, the house is the city of Buffalo and its unforgiving winters. The skyscraper might eventually be fixed, it might be reinforced, and it might even one day be filled with happy tenants. But the scars will always be there, hidden behind the high-end finishes in the form of thousands of feet of epoxy-filled cracks. A $700 million reminder that in the world of construction, you can't cheat the cold. You have to face it, test for it, and build for it from day one. Anything less is just a very expensive way to watch concrete fail. It serves as a stark warning to all of us who follow these massive projects. These feats of engineering are incredible, but they are also fragile. They rely on thousands of people doing thousands of things correctly. When just one of those things, like a frost test, is pushed aside for the sake of the schedule, the entire structure can fall into a spiral of failure. The Buffalo Project is a vivid illustration of this fragility, and it will be studied by engineering students for generations to come. Not for its height, not for its beauty, but for the lesson it teaches about the power of the frost and the danger of the shortcut. The story isn't over, and as the winter of 2026 continues, the eyes of the architectural world will remain fixed on Buffalo. They will be waiting for the next report, the next sensor reading, the next loud pop in the middle of the night. Every degree the temperature drops is a new stress test for a building that never got the one it really needed. It is a massive, high-stakes experiment happening in real time, and we can only hope that the engineers find a way to stabilize the glass giant before it becomes a complete loss. In the meantime, the cracks continue to spread, a silent evidence of a $700 million error that could have been avoided with just 60 seconds of patience and a commitment to doing things the right way.